Okay. Good afternoon. Welcome to the session on network access innovation. We have three speakers today, two of whom are very, very well known to the audience. I'll introduce them just before they speak. So network access innovation, the theme of this session is really about using SDN and virtualization technologies to make it easier, simpler, and in a more flexible way to be able to connect users to backbone networks. So we'll start very quickly with Diego. Diego Lopez is one of our very well-known speakers. He's been in the community for a very long time, been very active in the middleware field. He made the move away from us, and we all miss him. But in the meantime, he has acquired a new skill. Apart from being still a very good middleware developer, he's also now a cheese connoisseur and affineur. He's now a very good expert in Shropshire and this afwegalpitu. So if you have any questions on cheese during the break, you can ask Diego. He'll tell you all about it. But for now, up to your presentation. Thank you.
Thank you. Am I on? Yes. Thank you. Seriously, I hope for the next TNC I will be able to bring some samples. For now, it's only experiments, and well, some of them are promising and some of them are really discouraging, I must say. Well, the idea of this talk is basically introduce two things. One is something that has happened very recently and that was mentioned yesterday during the update on standards, which is all the principles or all the new principles that are establishing around what we call NFB. That will be, since I will tell you what means a little bit later because it's what half of the talk is going to be around, and how we are leveraging on precisely the Manticore, the technologies developed inside the Manticore technologies project, to provide NFB-enabled services in the access environment. So, well, the idea is, where shall I point? Here. Just to justify what is NFB, this is the comparison that we are using internally between the different development cycle that, on the one side, network service providers, and on the other side, content and application providers had to follow in the moment they want to deploy something new, a new service in the market. In the case of the NSP and a network service provider, it is very much right now dependent on equipment, on hardware, on that those hardware vendors being able to agree and standardize and go through lengthy process for the standardization, lengthy discussions, because there are lots of money involved there. So the typical cycle, since you have an initial idea, you have some initial hints that something is possible, until you're able to exploit this in the market, talking about between 2 and 6 years. And well, you can imagine that as NSPs look at the CAP that are called as well OTT, well, you can imagine who am I talking about, that from the moment they have an idea to the moment in which they have it available in the market, not necessarily standardized, not necessarily part of a complete deployment in agreement with other providers, is in the order of months, because they have a very business and services that are extremely intensive in software and only subject precisely to their development capabilities in those terms. The different ways in which we are dealing with this infinite task of releasing new services, inventing new things, deploying them, luring the users to use them, and luring them to and convincing them to pay for those services. Well, things are changing somehow, essentially, on the one hand, because virtualization in general is becoming pervasive. We're talking about everything can be or is suitable to be virtualized. The movement through the cloud infrastructures, virtualized data centers, etc., is becoming mainstream in all areas. You see that there are high performance industry standard servers, and we're not using, we were here precisely refraining from using brands or talking about here of Intel or ARM or whoever, because it's about that this is something that is standard. We should not care who is the manufacturer. More and more the limits between or among the different cooperating infrastructure layers, the network, the computing, the infrastructure, the storage, are blurring. Now it's difficult to say, no, this is pure storage or this is pure network. We have very good, and this is something that we have directly experimented, that virtualization technologies are now able to provide very, very good performance. Well, then we have this trend of software-defined networking, of everything becoming mobile, everyone willing to be connected from everywhere using their own device, etc. And for sure, I would say feeding up cloud services that are all over the place. On the other hand, network operators are facing, that you need to invest big piles of money to keep up with the user requirements, that revenues are lowering. I don't know if you were during the plenary on Monday where my colleague Pablo Rodriguez was showing the different curves of how traffic and costs are increasing and revenues are lowering simply because two reasons. There is stronger competition on the one hand, and second, the traditional sources of revenue are being drained by the use of internet services. There are much less SMS traffic right now because people use WhatsApp or Line or whatever. Things are becoming extremely complex. The install base of any network operator becomes extremely complex in the sense that you have to deal with disparate pieces of equipment from different vendors, different versions, different requirements, different ways of managing with them, and etc. But on the other hand, the hardware life cycles are being reduced in the sense that the obsolescence of the equipment comes much faster because the technology evolves very, very quick. And that brings that you have a very much static set or static infrastructure that is very difficult to adapt to new requirements, new technologies, to the launching of new services, and you have to deal with this, let's say, ossified environment, and you have to make this ossified environment work in an extremely agile world in which your competition or those that are going to overcome your services are moving much faster. So that brings to this idea essentially, which is what we're talking about. We're talking about network function virtualization. Bear in mind that we're not talking about network virtualization. We're not talking about not only about virtualizing the network view. We're talking about virtualizing the functions themselves inside the network. What we're talking about is that instead of having dedicated pieces of hardware that are providing network functionalities, essentially, more or less, probably we're not talking about a 1-to-1 mapping, but we're talking about one physical function or one physical node per function. What we're talking is to move in a much more virtualized environment in which you have software elements that are able to be deployed on top of high-volume standard servers, using high-volume standard storage, and relying on high-volume switches that are software-controlled. So instead of having a local access aggregator plus a BRAS plus an edge router, you end up with this kind of flexible environment in which you can try to freely deploy the pieces that come from your network services. We do think that would bring an extraordinary effect of scale, a reduction on geographical dispersion of hardware, so you can concentrate them, the equipment in a few physical locations, reducing the need of movement your stuff. And the possibility, which is extremely important, about reusing the hardware for different functions. So you can, depending on the image you're going to deploy, you will be providing one service or the other. All this brought us to the formalization of network function virtualization as a concept. That, if you allow me, just for the sake of brevity, just let me insist on the first point, which is that we're talking about essentially implementing network functions in software that is able to be run in a uniform hardware platform, which is that's the important thing. Essentially, that nowadays it's true that most of the current network functions are implemented in software. That's true. They are software running on dedicated equipment. We're not talking about not only about using software, we're talking about using software that can be moved from one equipment to other, and that can be moved from one equipment to other, and that equipment being uniform. It's not about virtualizing a high-end router. It's about implementing the same functions of the high-end router, so to say, to put it in a few words, in the cloud. So the idea is then you have multi-versioning, multi-tenancy, you have new ways that we have to explore to implement properties like resilience and service assurance and the famous 5 or 6 or 7 nines. Open the market to other players and facilitate innovation. And with the idea, said at the bottom, that we aim to, well, make an ultimate transformation in the way in which network services are going to be provided in the future. With this in mind, we started the ISG, the NFV ISG inside ETSI. Originally, there were, if I remember well, there were 6 operators in the funding, 6 network operators in the funding meeting. Now we have more than 100 member organizations participating in the ISG. With the exception of 2, as far as I know, all of them are either operators or industry, but the ISG is completely open. I know ETSI requires requires organization to pay a fee to become a member, but this is open to non-ETSI members as well. You just have to sign a participant agreement that essentially, well, is about an acknowledge of the IPR of ETSI, etc. And we will be more than happy to see academic organizations and, well, the GEANT, for example, participating here with us in this. It's something that is extremely promising. As I told you, formally we started in January or December or January around Christmas, the last Christmas. From that, the first meeting, to our surprise, gathered more than 200 people. The second meeting gathered more than 300. So next one that will be in Germany, well, I don't know. But I'm really concerned because the 5th one going to be in Spain in January as well. I don't know whether to look for a place for 600 or 700 people. That would be a real problem. Essentially, one of the important things that essentially right now we are focusing on is not a standards body. It's a way of identifying, because this is pure new thing. We want to explore the idea because we don't want to reinvent an additional set of standards. We want to reuse whatever is around. So the idea is to identify what we need, to map it to the existing standards in network virtualization, cloud management, software virtualization, service lifecycle, whatever, and identify which are the deltas that define what is common practice and what is new coming from NFV, and make an input to the standards bodies to ask them to move in that direction. And essentially, well, this is the organization. Right now, we have 4 working groups and 2 expert groups. The working groups are focused on general infrastructure, network and computing, the general software architecture, management and orchestration, and reliability and availability. And there is a couple of expert groups on security and performance. Well, this is this is draft still, but, well, it's quite, most of the people is in agreement of this is the general architecture for the NFV conceptual framework. let me go very fast in the idea that everything that is in pink or cyan or magenta or whatever you call that color is something that is already part of the current network practice, the shared state policies, etc., that you share inside the network, how local state is maintained at any node, and how you run your operations systems. Here is what is common currently in cloud. You have a cloud management system, you have machine for storage, you have operating system, you have hypervisors, etc. And here is what is common right now in data center and in local networking or infrastructure networking that is common. And in yellow, if you look at it, in yellow you have what we think is new. What that means, you need a new way of deal with the virtualized network infrastructure because things change. You don't have a box any longer. You need to have mechanism for interfacing with to define up to the rest of the network how the virtualized network functions are. And most of all, you need to orchestrate and manage the whole thing, because that changes completely. You have a virtual box or a virtual and geographically distributed box that you have to manage. You have to deploy. You have to monitor, and you have to take care of. And this is essential. And what we're trying to do is precisely, well, taking into account that the management and orchestration is key for this, what they're trying to do is, as I told you, to avoid reinventing the wheel here. We acknowledge there is a lot of things already done when it comes to network operation and when it comes to cloud management in general. Whenever we start talking about that, somebody says, what about OpenStack? Yes, exactly. We're talking about OpenStack and everything that happens around. We don't want to make additional noise, and something that is important is that this opens, certainly, is promising, but that opens a lot of additional potential problems. Incompatibilities in practice between cloud and network operations, additional complexity. We want to solve complexity, but we don't want to solve complexity by adding a different kind of complexity. This is something in several SDN conferences I have been before. There is some guy that is from network operations stands up and tells, well, no, everything is going to be software. So everything is solved because software magically comes down from somewhere and say, no, you are saved. The fact is that you have developed and run software in the past. You know that software can bring extremely big problems, even more than hardware. Hardware, normally you physically change the thing and you are done. In software, even if you physically change the software, many times things don't work. So we don't want to add this additional complexity. And for sure, there are new security issues that we have to consider. But we know as well, 5 minutes only, okay. We know as well that the ground is completely new. So we want to go a little bit beyond or think a little bit out of the box. We want to go beyond the virtual whatever. We don't want to develop a virtual router, a virtual firewall, a virtual load balancer. In cloud environment, something that is important is that most cloud software is based on the 3-tier web application. Typical, I have the presentation logic, the business logic, the data support. This is not applicable in network at all, so we had to reinvent new architecture for this. We had to go beyond, a little bit beyond the pure infrastructure as a service, because we are using network for supporting and as a service we are providing, and we had to know much more about how orchestration is organized. And we want to follow a extremely evolutionary approach in the sense that we are operators, we are extremely conservative. Well, not we. I mean, I work for research. We are not conservative. But when you go to the operations guys, they are extremely conservative, and they are extremely concerned about you making them waste money, time, and effort in something that is not going to deliver. So our idea is to go step by step, identifying relevant use case, make phase deployments, and take advantage of the NFV advantages when it comes to flexibility, extensibility, reusability, to make step-by-step integration. And where the Open Network as a Service plays in the orchestration because we have been working with the software, and one of the essential properties it has is that it allows us to abstract the physical implementation. So the idea is that we can provide an integrated orchestration, whether you are complying with the NFV principles or you're using physical infrastructure. You can make a general mix of, so to say, legacy and NFV environment in which you can deploy your services, and you can somehow hide this additional complexity to the people that are running the operations. And this is something that we have been, you can rely on certain principles that are extremely important for the orchestration that are provided by the framework, like security, lifecycle management, monitoring, taking care of deployment and a grade of the different elements in the infrastructure, and how to make the general service orchestration. The use case we're considering is how to provide a virtual residential gateway for a GPON subscriber, fiber to the home, the place in which you are going to deploy the fiber. So the idea is that we started thinking about something like this, which is about, the architecture is about bringing everything that is in the user environment and the household, so to say, everything that is an edge to layer 3, moving it to our infrastructure. So you have layer 2 visibility all through everything that is installed at the user premises. That means that you can provide additional services based on something that we have begun to call the Virtual Software Execution Environment, the VC. So the idea is that you can provide the personal cloud services with ideas of providing things like, home automation, high quality video, 3D media, games, etc. And that having this, you have all the elements that constitute the edge, the layer 3 edge of your network inside your data center, and you're providing and managing the services from there. That means we have made some calculations just to give you an idea. We think that depending on user services, the operational savings of this approach will be between 15 and 40%. And again, since we are moving in the direction of being an incremental deployment, we think that the additional CapEx that you're incurring because of deploying the new virtualized environment can be compensated by the OpEx savings and by aligning with the natural replacement of home gateways at users' homes. And again, having this network of NAS layer on top will facilitate to make it in a phased approach. These are the ideas that, the things that we think that this approach, the virtual home CPE, would enable. Services based on universal plug and play, managed security, a personalized data center, to make user mobility, which is something that we have been thinking very much about, this about having user mobility, not terminal mobility. So you go wherever you go, you identify yourself and you are there, and you have your services. Facilitate new service deployment, and IPv6 migration has been an extremely relevant use case for us for a long time for selling this internally. And something that identity-based services that are somehow connected with this user mobility. And in some cases, NAS itself for advanced users, and we're thinking about, well, enhanced OTT services or VPNs. And this is just at conclusion. We strongly believe that the network function virtualization is about to change the network landscape in the coming years. Apparently, many other things the same, and this is why we are moving around this ISG under ETSI. There are very strong drivers in terms of the amount of money we are going to save, but not only on that, it's about having much shorter service cycles and the opportunities for providing new services and new service models. That is more important as well. Very important. It's about precisely finding new ways to architect and operate networks, and to open and to have an open innovation environment that is important to us as well. And we see a lot of fields of application. The number of use cases we have been discussing inside the NFV ISG is enormous. People is proposing experimenting with virtualization of almost anything. Not everything, because there are things that need to be physical, but I would say 90%. And we have found that is using the network as a service model, applying an evolutionary approach is possible. And this is very important as well, because in an operational environment, not having this 0 day is an essential characteristic of whatever you try to accomplish. And as far as I can tell, that's all. Thank you very much. And
Thank you. Thank you, Diego. So, the floor is open for questions to Diego.
Hi, I'm Jorge Bair from FCCN. You were talking about the network as a service, and it was most of it. But I really catch up on the virtual execution environment that we're saying. You are trying to, as an operator, you are going to provide infrastructure within data center to execute applications for your user. Okay. Mm-hmm. What if the user could also provide some computing power to that virtual execution? Okay, that is the first question. And then the second question is, what if that virtual user application environment could be open source or available through APIs, and then we could share our user capability to process computing data and big data and so on. So
why not? No.
It's
seriously.
another use case.
No. And I love that idea. I mean, it's something that we try to insist very much when talking about all these ideas on NFV. Precisely, it's about these opportunities for new service models and this opportunity for new market players. This is something that I would not say that all people inside all operators that are participating in this think the same. Mm-hmm. This is now I should start about this. This is my personal opinion and not of my employer. But anyway, many of us strongly believe that one of the things that we have to do is to, somehow give a strong shuffle on how network services have been provided so far. And we have to explore this. And this idea, for example, the idea of open source somehow is something that we are experimenting with. We are now about to start a project together with a couple of universities, one in Italy and the other one in the UK, precisely on this. On the idea, very much focused to security, but it's the idea of having a virtual software execution environment in which you can load some security applications that you have decided that are the ones that better fit your needs. Okay. And the idea of sharing those applications probably could fit inside the...
because you could have an app store on your cloud.
And
then
exactly.
users will buy
applications. Or use, as long as they...
By use, yes.
No, in many cases, for example, one of the things that we are facing right now is about... It's more, in some cases, it's more relevant to reduce user churn. People going to another operator because they got a better deal for 6 months and coming back to you once and again. That making money out of selling the service. If you convince them that you are with you, they are in the best position they could achieve. That's in many cases would be enough.
Just another use case. Gaming, rendering gaming online on the data center.
Yeah, I'm making some kind of,
Okay.
Thank you.
Okay. Any more?
Oh, Tim.
Thanks. So how does this sit with having home networks or more advanced, perhaps IPv6 home networks with multiple routers for various reasons in the network, the ability to operate your network or the network to continue to operate if your ISP goes offline or has some problem?
Yeah, this is the other. Well, I would say that in the case of all these discussions inside of having the huge home networking, which is on your own. Well, here you can think about having, if you have different providers, you can think of having different LAN segments that are landing at your home, and you decided to route them on your own. Because it's your home network. It's not your operator network. Instead of having layer 3 visibility, you will have layer 2, and you route between this, you route, or even you can decide to switch. Why not? This is not necessarily against the idea that you can have different providers, different network services, etc. The only thing is that you will have them at layer 2 instead of layer 3, and each operator will see layer 2 with it.
Well, in the IETF, the home networking group there is considering that you would almost certainly have future rooted networks because of disparate types of media, guest networks, corporate extensions, etc., etc. So I think as long as this supports that and gives you independent operation, should there be a problem?
This is something that we have been discussing precisely about how this fits with all movements, mostly when dealing with a B6 deployment and you having at home the whole internet address space that you have now. I think they are not necessarily incompatible, but harmonizing them is something that we had to think about a little bit, and this is in our list of to-do things. Certainly.
Okay, thank you. I think we don't have time for more questions, and there don't seem to be any more anyway. So thanks very much, Diego.
Thank you.
And I invite now our second speaker, Łukasz Podleski from PSNC. Łukasz has recently graduated in a discipline which is quite different from what we are accustomed to in musicology, but he also has a degree in computer science. So he is also an expert in the things that we are familiar with. And Łukasz is going to speak to us about the Adonis project, about Next Generation Access Network. Thank you.
Thank you very much for introduction. Welcome everyone for my presentation. Next 20 minutes I will try to show you the new architecture for metro access networks, architecture which mostly takes benefits from the SDN approach. I will show it on the example of the Adonis project, after distributed and dynamic optical network access systems. So first of all, at the beginning of our project, we've faced with number of problems that are faced in the today's access metro networks, and among others, the most important one that we cannot, in the metro and access network, we cannot guarantee quality of the services. We cannot we cannot provide to the user more than one service. We cannot support multiple operators on over one physical infrastructure, and one of the most important is also that end users are increasingly becoming content providers. They would like to share photos, videos from the vacation to other users. They are basically becoming service providers, for which current metro architecture is not prepared. From taking above into consideration, we came into the functional requirements which our system should fulfill. First of all, virtualization of the network resources to allow multiple infrastructure operators of virtual infrastructure operator to share one infrastructure in order to provide many services. Then dynamic bandwidth allocation to provide to the users more guaranteed services with guaranteed quality. For that, also symmetric user-to-network links, which will allow us to simultaneously downloading and uploading huge data. Yeah. In our solution that we have, there is nowadays solution where we have multiple infrastructure providers in the metro area, which are offering access to the services, but we have facing mostly with the triple play model where infrastructure provider can offer access to the VoIP, internet, and IPTV services to the group of directly connected users to this infrastructure operator. In our solution, we are proposing having one infrastructure provider on the metro area network, which is offering access to the physical infrastructure, using which virtual service operators might have a slice of these resources, and providing access to the users offered access to the users for services provided by the service operators. But the most important thing here is that service providers are connected directly to the infrastructure, where each VSO, each virtual service operator, might gain access to these services. Here, as you can see, is infrastructure provider, virtual service operator, which obtains slice of the physical infrastructure from the infrastructure provider, has arrangement with the set of service providers and users in order to provide services to them. And we have, of course, service providers which provides content and service to each of them. On this slide, we can see that each service operator or user may interact in the same time with the many virtual service operators. Each virtual service operator possesses its own virtual infrastructure on which he can build network connections. From the user perspective, we might have many models, but the most basic one is that the user is contacting directly with the virtual service operator portal, and via that portal is obtaining services. But the second one, I think more interesting, is that user might surfing via the internet came into the service provider's portal, and then service provider seamlessly will establish a dedicated path, dedicated connection to the user in order to provide its service with guaranteed quality of experience. That leads us to the SDN approach, which in particular open flow technology, which enables us to fast and dynamic reconfiguration of the network end-to-end connections, allows us to easily visualizing the network infrastructure. And the most important advantage of the open flow itself is flexibility and granularity. Using open flow, we are able to very granular defining traffic or connections path, dedicated path to the user, which each of this traffic might be directly connected with the content of the content hosted by the service provider. Here is our SDN reference architecture. At the bottom, we have physical infrastructure, which is active optical access for symmetric end user services. Then we have a network resources management and networking policies. We have used FlowVisor in order to virtualize a network physical infrastructure. We have VSO Manager on the right-hand side, which is configuring the slices for virtual service operators. And on the left-hand side, we do have a virtual service operator, which consists of service layer, which is responsible for managing services, users, accounting, and so on, and network operating system, control layer, which basically is responsible for setup connections and for managing this slice of physical infrastructure. On the later presentation, I will be focused on the control layer element. Here is a data plane architecture in our project, which we have, among others, partners. We do have Kima and Intune, which they provide devices for our solution. Kima provides access switch, which is providing symmetric 1 Gbps link to the user. And Intune provides OPST distributed three-stage switch, which interconnects endpoints in the full mesh topology. Main entities of the control layer architecture, which I will describe later, is endpoint, which is physical virtual termination point, service, which is definition of the traffic, and virtual square network, which is dedicated path to the user. As I said, endpoints are physical, like users' access devices, or physical servers, or virtual, like users or service providers virtual machines located in data centers, entities present in the architecture. Each endpoint registered in the control layer can provide services in the Adonis solution, this regardless if this endpoint is user endpoint or service provider's dedicated server. And each endpoint can also obtain access to the other services, providing by other endpoints. Services basically defines traffic requirements for data transported using this virtual networks. Each service consists of 3 elements, which I will describe later. But use of OpenFlow enables traffic definition for servers with very fine granularity, from pure layer 2 connections to layer 4 TCP UDP ports. And that allows us to better network resources utilization and control better than nowadays layer 2, layer 3 solutions. Now, each service has reserved bandwidth for its own purposes, virtual network for the virtual network to the customers, and he has full control over throughput resources. Here we can see a service data model. Each service is defined per direction. So here we can see traffic definition, which we have a link type, upstream and downstream. Each traffic might be unicast or multicast because it is a different pattern. Network type, it is a point-to-point, point-to-multipoint, or multipoint to multipoint. Yes, and flow policies, which are describing how the traffic, what traffic will be transported by the virtual network. Virtual network represents a dedicated path with guaranteed quality of experience from the customer endpoints to the service provider servers. Virtual networks path is created using traffic definition of the service, and each endpoint can have established many virtual networks at the same time. And now, using that, because each endpoint can have established many virtual networks, we are going into multiplay model instead of triple play. We are not limited only to the VoIP, IPTV services, and internet access. At the moment, we have released first prototype of the control layer and OpenFlow agents for supporting non-OpenFlow devices, and they're ready and tested. First prototype of the service layer is also ready, and work on the slice supervisor, slice resources management are in progress. As high-level view on the Adonis testbed. Our testbed at the moment here at the top consists of virtual machines for service layers and control layer, as well as a set of switches. Here we have customer premises equipment, Milegate node, and 2 Juniper's MX80 routers with OpenFlow support, which has been virtualized into the 4 nodes. Yeah. And that is more high-level look on our Adonis testbed. Service provider, we do have a portal, which I will be happy to show you on the demo. We have control layer here on the left-hand side, and Zixel set-top boxes. That is in one of the quarters in Poland. And then we have look on the Juniper's MX80 routers. Our solution, our architecture supports, first of all, multiple operators, because virtual service operator might be, we might have many virtual operators at the same time. Each of them has full control over its slice and its resources, so we can have control layer might be in a centralized fashion or distributed one, that is regardless from the taking into consideration our architecture. We have end user that can act as a content provider to share photos or massive multiplayer games in the network. We have quality guarantees for delivered services in terms of traffic definition, which I have shown previously, and throughput of the network. We have flexibility in changing network operators by the end user, because in the one moment, user can be connected with one virtual service operator, and another moment the second one. And we are dynamically setting the services. Our project started in 2011. We are duration 24 months. Our consortium consists of Poznań Supercomputing and Networking Center, which is project coordinator. We have Intune Network Belfast, University of Belfast, and Compound Semiconductor Technologies Global from the United Kingdom, and Kimal from Germany, which, along with Intune, are providing dedicated network. Our web page is adonas.eu. So, that will be all from my side. Thank you for your attention. And after the presentation, I'll be happy to show you a short demo at the Pioneer PCNC booth, number 14.
Okay.
So, thank you.
So again, the floor is open to questions. To Lukasz.
How you were talking about dynamic provisioning of services. What would you consider to be dynamic provisioning? How long does it take to provision a service?
How long to set up a path?
To provision to set up a path, to set up a virtual network, to provision the service.
Setup path is going. It's matter of milliseconds at the moment in our demo setup. About accounting, we are able to measure the traffic using flow meters, and
Okay.
Thank you.
Any more questions? Yes. Tim and Diego. Yeah. Oh, I saw your hand first, Tim. Sorry.
So a couple of quick questions. I think this is pretty interesting. The first is, I may have missed it, sorry. What sort of authentication and authorization models are you using for adding the different policies? So for example, it might be that there's an IPTV service. It might be that I want to make sure my World of Warcraft runs quickly if Blizzard support that type of provisioning in my system. And the second question is, could this just run in an OpenFlow compliant OpenWrt type system in a home network without necessarily doing any virtualization? So 2 questions.
Answering for the last one, the beginning, yes, no virtualization is possible. So we might have only one virtual service operator, or that way it would be just a service operator. About authentication and authorization, from the control layer point of view, there is no such thing. We are only interested in the endpoints which are obtaining. We are setting up the dedicated path to the endpoint. Authorization is done in the service layer. So from the request going, I will come back maybe to one of the models. Yep, here. When user is going through the internet to the service provider, for example, or virtual service operator, his IP addresses might be obtained from the HT from the packet, and that is identifying endpoint in the architecture. And because of that, virtual service operator might, for example, extend slice to reach this endpoint, or maybe it might be in his slice, and set up the path. Or authorization is based on the upper layer at the moment.
So,
Go ahead, yes.
no, it was precisely about asking about the security, the security model in general. This is when it relates to the user. And what about the virtual service operator? How do you establish rights and authentication or authorization of the service operators themselves? Because they are supposed to be somehow, they could interfere one another. How do you guarantee the multi-tenancy bats separated?
All service provider which has or possess endpoints in the architecture possess it. Endpoint might be virtual server for which service provider may use, or physical server. And that endpoint has to be registered in the control layer using its MAC address and port on the switch.
So it's physical, so to say.
Physical. But in the virtual one, virtual service operator might, it is we are focusing in the virtual machines also, in the virtual environment, and then virtual service operator can create a virtual machine in the cloud environment, distributed data center environment, in order to provide services for him. So basically, one endpoint might be registered in many virtual service operators by its MAC address.
So you're oriented the security. I mean the authorization authentication, at least for the service operators, is based on the endpoint location and endpoint
Yes.
characterization. Okay.
Yes.
Any other questions, comments? No? Okay. Thanks very much, Lucas.
So thank you very much.
And last but not least, of course, we have another very well-known speaker, Dave Wilson, who's been working since the last century, I think, at HCANet, like I have as well, not for HCANet, but Dave is very active in both the Giant and wider networking community. And he does this without ever having studied networking. So he must be genetically wired to understand these things and develop them as well as anybody could. So, floor to you.
Thank you, Roberto. No, it's true. I think it actually helped. I did study computer science, and I was the only person in my course not to do the networking course. We'll be going to my alma mater next year for TNC 2014, so let's just keep that inside this room. Thank you. I'm Dave Wilson, and in HCANet, we've been dealing with the problem of, much like Diego was saying, our CPE, client premises equipment. We take quite a lot of equipment, and we litter the floors and racks of our clients with it. And we decided to take a look at this. And in taking a look at it, we thought, as an NREN, we have our customers have the same pressures as enterprises do. They have to deliver reliable internet services to their users, and they have to do this with keeping costs down and so on, and keeping the reliability up. And we're putting all this equipment around the place, and we started to wonder, what does it all do? Anyone tell me what a firewall does? Firewall, that's easy, implements a security policy. You put it on the border, and the policy passes in and out. Fine. What does a switch do? Switch provides network connectivity at a given speed. And if you want to upgrade the speed of your network, you upgrade the speed of the switch. Fine. Transmission equipment, what does this do? That's even easier. That's speed over a distance. And the further you need to drive it, or the faster you need to drive it, then that determines the equipment you need. What are routers for? Anyone? Any hands? There's a t-shirt in it for you if you can tell me what a router does. Is that down the back? Yeah?
Rewriting headers.
Rewriting headers. What's that for?
Deciding which interface it should go.
That's what switches do, right? Deciding what interfaces they go out.
Into networking? Yeah.
Into networking. Bang on. T-shirts for both of you. Round of applause, ladies and gents. Which gives me time to get down to both. This is yours. Thank you. And yours. Thank you. Because I went through this and I went, is it about the bandwidth? It's not. Is it about the connectivity? It's not really. That's a transmission. Is it about resilience? And I thought resilience have cracked it, but no, because in order to have resilience, you need two of the things. It's the I and iOS, it's internetworking. It's about separating networks. It's so I can manage my network and you can manage yours, and we can keep them sensibly separate without one bothering the other. So I thought, what do we need to actually do this? And I took a trolley into our test lab and I started piling up equipment. And this is the kind of stuff we put in our clients' premises. I need a router. Fine, this is my CPE. The customer also needs a router, so they can match it and they can manage their part. We separate between, I have my network and they have theirs. Fine. But of course, we want resilient networks, so we need two more. Okay, that's not crazy yet, that's fine. Then, being a forward-looking network with innovative services, we want to put a switch out there because we might want to do things that don't happen on the IP router or do something else exciting. And because we need resilience, we put a second switch out there. And then the customer will have to match that with a firewall. And for resilience, match with a second firewall. This is too much. It can't be necessary to have all these different pieces of tin blocking a fire exit just to get this job done. So we thought, is there something that we can do about this? And indeed, all the cable. I didn't even start with the cables. But this is no t-shirt though. I'm sorry. This is the problems, like Diego was saying earlier. The problems we have with CPE is there's the initial cost of the things. There's the ongoing cost, a maintenance cost, which is a function of the initial cost. And then there's just the sheer operational complexity of managing all this equipment. And there must be something we can do about that. And I went back and I thought, why not do all this with just one great big router in the center of the network, like we used to? And there's a reason we used to do it and don't anymore. And that is that every client network has different needs and has different requirements, needs to operate in a different way, and we need to separate them out. And if we fix our configuration so that it's one client, that's probably going to conflict with the needs of another client. It just doesn't work like that. So we need a separation. But separation is a job that's done in software. You can virtualize software. We've been virtualizing this stuff for years. I mean, if you take a PC and say, I want it to pretend to be several different PCs running different copies of Windows or Linux or what have you to different people, you can do that with routers. And this is what happens. This is exactly what happens with Junos. In Juniper routers, you can have different logical routers for different users, each with their own forwarding plane, each with their own authentication. So what we're doing, and this isn't a new model, SUNET have been doing this for years, where we thought we'll take away the routers that we have on each premises and replace those with 2 or 3 or a small number of aggregated access routers, if you like, close to the core, and configure the network like that. And in detail, it looks like this. I have a router. At the moment, we're still running this in the lab. We're hoping to have customers on it very soon, actually, like end of this month sort of thing. But at the moment, I have a router in the test lab in Dublin City Centre and in our data centre in Park West on the western side of Dublin. And we want to make a couple of virtual routers, logical routers, and they're going to need connectivity. What connectivity does CPE need? Well, we need links upstream to get to the internet. We need a link in between for failover. And we need links downstream to the local LAN. We've sat through a lot of PowerPoint today. Would you like to see it in action? I'll take that as a yes. Cool, thank you for switching. Let me show you. This is a graphical user interface, and I'll talk a bit more in a moment about how it's put together. But for the moment, let me pick this particular use case, which is CPE for a single provider. That's a representation of the physical equipment we're about to use. It's not the most interesting part because this is. What's coming up here is the logical network that I'd like to build. And the principle we have here is that it should be possible to specify the parts of your network once and only once, and then have that information inherited anywhere else that information is needed. So you specify the interfaces you need once and only once, rather than again for BGP and again for OSPF and again for something else. So I have a setup here. It happens that the tool is actually sensible enough to specify suggested VLANs and suggested IP addresses given the information it has. There are certain restrictions going on in our lab, so we have certain things set up for it to allow it, so I'm going to fill those in. We get from there, what else do you need? Okay, we have our upstream interfaces. Next thing we need routing, and in HCN we use BGP. So to make that work, we need the client has an AS number, the upstream has an AS number, and we agree what prefixes we're going to exchange. Then we get into the actual topology. This is where I'm actually designing the network itself. I want loopback interfaces on my routers because I like that. And I happen to know that I have certain VLANs available for connecting in between. Now, what the hell are these doing? Well, these VLANs don't currently exist. These circuits are not yet configured. And this is going to be configured on HEN's production point-to-point network. We need, like I said before, downstream links for the master and for the backup, and we need a link in between. And this is going to go through the bandwidth on demand system. Why not? Same network that we use for that, we can use for everything else. And we make the requests that way as well. That's all very well. That gets me the equipment that I'm used to providing for the client, and me the access I need. But what about the client? Because they also have requirements of this equipment. They have things that they need to be able to do and need to be able to configure. For ERP, they're probably going to need that set up. Let's give the network a name. My favorite button, because like I said, we're able to inherit the config all the way down. Would you like OSPF, yes or no? Simple as that. And an interface for firewall filters. So let me push this button. And if you can switch back to the slides for a few minutes, thank you very much. That's going to take a couple of minutes to run because, well, I'll explain why, because we're going to be, like I said, setting up circuits on a live system. So those are now requested and the configuration is underway. So let me explain while it's doing that, why we're doing it in this way. Excuse me. There's sort of three big ideas we have here. And the first is on-demand provisioning. There are a bunch of ways, there are kind of different ways to solve this, but we see three big ingredients to this recipe. And the first one is on-demand provisioning. And let's go back to this grid that I had a few minutes ago, and let's see what we solved. The initial cost, because we're virtualizing this and we're able to set it up automatically, is lower. The maintenance cost, again, because we're able to aggregate, is lower. The operational management, because we're automating it, that's not really solved. We still have all these, just because we virtualize this equipment, we still have to deal with the equipment. The network is still just as complex as it was before, arguably more complex, because at least when worst came to worst, I could always go to a batch of routers or switches and start pulling things out until I understood what broke and then get to fixing it. And you can't even do that with virtual devices anymore. So we still have a problem here. How do we solve that? Well, we found we solved this in HEN a few years ago with the point-to-point network, the one I'm talking about using now, because when we implemented it, HEN only has, for third-level customers, we only have about 60 clients. And it would have been very easy for us to set up our fiber network and our point-to-point network and manually configure it and leave it, and it would have been fine. But we went the extra 10% and put in an automatic provisioning system, and it gave us some wonderful benefits. The first and foremost among which was change control suddenly became much less of a hassle. Anytime I wanted to make a change, we knew exactly what was going to happen because it had done it literally thousands of times before. We know exactly what this thing is going to do. You don't have to rely on an unreliable human being like me to set up a data or to fix up a database after I make a change. Same with monitoring. And best of all, the other best of all, is it gives access to anyone we wish to give access to and no one else. If we want to allow permission for someone else to be able to access a point-to-point network and set up connections between certain ports, we can allow them to do so if we wish to. So we thought, that's very powerful. Those are great benefits. Can we bring them to layer 3? And like Diego was saying, that's where OpenNAS comes in. We worked with ITOCAT and the other partners you saw on the first slide to build this software. And what it gets us then, what is it? It's a framework for network as a service. What's a framework in this context? Well, I need a provisioning system. I can make a provisioning system for my services out of this. But someone else who's using it in a different way will get a different product out of it. It's open source. There's you can download it today, right now. There's a command line interface and a RESTful API, which is how we developed the GUI that you saw there. And it's integrated with Bandwidth on Demand. And that was the benefit for me there, because instead of setting up a special way to interface with HEANet's point-to-point network, we're able to just go straight to Bandwidth on Demand and make the same request, even though that request lies entirely inside HEANet. We thought, why not do it that way? So that's the on-demand provisioning. That's all very well. The second part of this recipe is we need to provide abstractions. We need to represent these as resources. Who do we provide these abstractions to? Well, that depends on who you want to serve with this. It could be a customer who you want to give access to. It could be your own network operations center, which is how we're starting to see it. And the way that this pulls together is we have, like I said, the OpenNAS framework. Bunch of building blocks here. I won't go into detail on every one of them. The two really interesting parts are, here's my physical network, and here are the resources that we use and that we expose. And I'm a layer 3 guy, and I'm, if I go in on Monday morning and I have work to do, I'm not dealing with this. I'm pulling out the parts that I need, and I'm delivering the service that I want, using the building blocks that I want to provide to my customers, and that make up the services that we offer. So that's great for the, that's layer 3, and I'm a layer 3 guy. But if you're building a network, layer 3 isn't enough. You need connectivity as well. And where does the connectivity come from? Like I said, it comes from our point-to-point network. And the big benefit of using, not going in directly, but of using the band-on-demand system is we get the ability, if a customer wants to do something wider than virtual CPE, here's my ulterior motive. It starts at virtual CPE, but it doesn't end there. If they want to do something new, at the moment, what I have to do, if they need a connection, say, to Copenhagen, for example, today or yesterday, what I'd have to do is go, okay, give me a while, let me design the network, let me order the equipment, and let me send you the bill, and we'll have it up in a few months. And now I'm able to go, I happen to have equipment in this other city, let me just provision this circuit for you through the same tool, and turn a handle, and is this the network that you were looking for? No, it wasn't? Okay, hang on, I'll tear it down and try again. So, that's part number 2. And the third sort of element of this recipe is delegation to the customer or to whoever the end user is. We have, like I said earlier, the problem that we have one piece of equipment, which is the customer premises equipment, trying to solve 2 problems. It's doing these things for me as a provider, where I have these configurations, which if the client were to try and change them without us making a matching change on our side, all it would do is break their connection. It does nothing productive. On the other hand, that very same piece of equipment, managed by the same individuals, also has these configs that the client needs that are appropriate to the client's network. And if I so much as touch these, all I'm doing is breaking their network. And we thought there must be a better way to manage this rather than them mailing us to a config change, or us very nicely asking them if they can make a BGP change when we need to do so. Let's take a look at that, actually. If you will be so kind as to switch back to the laptop, thank you. Did it work? Of course it worked. It always works. Why would you think it wouldn't work? This is the completed network has been set up. And I have my list of networks on the left-hand side. But let me show you a couple of things here. If I switch here, this is the command line for the software. And what we're able to do with this is the GUI that I showed you, quite restrictive. It does one job, and the job is set up a network of this shape in this place with these pre-configurations, and that's fine. But I'm also able to see all the resources that I have exposed and manipulate them on the command line if I wish to. So one of the interesting parts here is I have not just my physical routers, also my logical routers available, also this thing called a VCPE net. The network itself, the entire network that we just created, is a resource, and you can perform operations on that resource. You can say, for example, OSPF, yes or no, please, and have it take place on that network. That translates to some quite practical things. This is one of the routers that we're using, and you see there's an existing router, W1log, that's currently in use, and then here's the one that I just created. We have our interfaces set up, we have BGP set up, we have the filtering already applied. And just to prove that there is nothing up my sleeve, I can go back here, and I have a webcam set up on my desk, which is connected only through this particular network. That is right now. The weather in Dublin is remarkably sunny, but I'm still very pleased to be here. And when I tear down this network, it's going to go away. So let me show you, if we have time, one more thing on the GUI. Do I still have time?
Yeah.
Thank you. Let me, as I said, we have the problem of providing access or providing one piece of equipment, providing different functions to different people, to the provider and to the client. Let me log out here. Let me log back in, not as the network operations center, but as the client. And what view do I get? Again, I see the network that has been assigned to me, but the operations I can perform are more limited. I have visibility of the provider setup, but I have full access to the things that affect the south side, if you like, of this router. And I can change them, edit them, and submit them. I can't delete them. If I want to delete them, that's one operation that is reserved for the NOC. And I have to go back here and push this button. Thank you, if you wouldn't mind switching back to the slides. So, where does that leave us? Well, I'm a big fan of automation, and here's a guy who knew about automation. Why should you deploy this? Henry Ford said, if you need a machine and you don't spend the money and buy it, you will ultimately find that you have paid for your machine and you still don't have it. On the other hand, we've all seen an awful lot of projects that demo really well, and look pretty good, but are quite difficult to deploy. And I think it was speaking about near-field communication, NFC on mobile phones. A senior Visa executive was quoted as saying he's seen more pilots than the RAF. So what's the difference here? What's the big benefit? Well, as I see it, this is something that we always need to be able to deploy incrementally. I'm long past the days of going, if only we threw out our existing perfectly working network and put in something else better, then it will be better. And the world doesn't work like that. This is something that we're able to put in alongside our existing network, migrate clients one by one as we get comfortable with it. And as we get more comfortable with it, then we start to proceed. And we're going to be beginning that very soon. But what we have today, right now, is where we are. We have this one thing, which is virtual CPE. A couple of takes on it, because Dyke in Denmark have a different view on this. There are also other things you can do with the tool. But the one that I'm showing you today, that we know works very well indeed, is this virtual CPE setup. We have like a simple OSPF setup. You can do more complex things. But the use case wasn't in there in VCP so much. We have this dual star BGP network, simple VRP. And if you download and try it out right now, which you can do, that's what you get. There's plenty more we'd love to do. I'd love to see a more generalized graphical user interface. There's more expensive IPv6 support. There is v6 support in there, but it's not finished yet. And of course, more platforms. But that's where I come and I say, we'd love to see more people involved in this. This has been run as an FP7 funded project, which is coming to an end this month, as it happens. But the software development and the software project has always been conceived of as an open source project, and that infrastructure is going to continue past the end of the project. So this is now actually brilliant time for anyone who is interested by this. Please come talk to us, get involved, and indeed sign up on the mailing lists and keep in touch. So I think this has a foundation of something that we can make useful not only for ourselves in HEN and for the other partners, but an even more generic tool that we can make useful to everyone in this room. And I'd love to put it in your hands. Thank you very much indeed.
Thanks, Dave. Questions? I'm sure there are.
Please.
Can you hear me?
I can now, yeah.
Thank you. I think that was a very energetic presentation. I really appreciated that. Have you thought of turning the problem around and getting the customer to provide you with a virtual CPE?
Funnily enough, that is actually very close to the Danish use case that we're covering, where we have a single network with two providers, and you have kind of the same problem but backwards, where different providers need access to this equipment to be able to handle their own configs without interacting with each other. And you can well imagine they must not be able to interfere with each other. I see that as I do see that as a more generic abstraction, if you like, of the same problem we're trying to solve. And I think, while I don't have the GUI for that today, I think it's certainly something to be interested in.
I ask specifically because from our perspective, the reason for demarcation is we want a point where we can, when we do troubleshooting, to say that we now know that it works up to where it should work for us.
Yep.
The problem is yours. And so we don't necessarily worry so much as the client might worry about, do I really want my firewall to sit inside your equipment? To some extent be under your control. So if we could address the demarcation problem to say, well, there is something there that we can speak SNMP to see, well, we're seeing packets, then we have our problem solved.
Yep. It's the sort of thing that, I mean, this is why we're following it as a pilot in HEN, and we want to see. I think we're going to run into problems that we solved one way that we will need to solve a different way, and we'll have to explore these. Did you already get a T-shirt? Okay, thank you.
So anyone else for any more T-shirts? Do you have any T-shirts left?
I have one left.
You have one left, so...
This works great. I'm doing this in future.
Hi. Are you using NSI for the bandwidth on demand?
Looking at the other part. Tanguy, please. Thank you.
Yeah, well, it's an adapter to NSI version 1, and the Autobahn platform, I mean, the Bank on-demand service is going to be NSI 2 compliant by the end of the year when the NSI 2 standard is published and when we're done with the testing.
So I'll just repeat that to make sure it's on the microphone. There's an adapter for NSI version 1, and NSI version 2 is going to be complete at the end of the year for on-band on demand. So we'll be looking at that then. Is that all right?
And the Junipers are with NetConf?
NetConf.
Okay.
Cool. Thank you very much.
Thank you.
Okay.
So T-shirts are run out, but there's still time for questions if you... Brian, yeah.
It's actually more of an answer, but... sorry, just in relation to your question, I'm the Network Operations Manager for HEANet. So as Dave was saying, it is a trial that we're looking at. And one of the questions we're going to be answering is, how we go about interacting with that and how we go about monitoring that. With our model at the moment, there will always be a device on site. There will be a switch from our layer 2 network, which we'll still have access to. And part of my thinking on this certainly is it's a cost saving for our clients as well, that we're investing in this equipment, so they won't have to do cost recovery on the routers that we would normally put in place for them. We would still envisage that they would, certainly in the initial phases of this, we would still envisage that they would be plugging their firewall or some device into our switch, and just the layer 3 intelligence would be centralized and virtualized. Now, what happens in 2 years' time when we look at our network again aggressively is another question. But that's certainly going to be the initial trial and the initial production, assuming we get to that point. But which I assume we will, but the initial production setup.
Thank you very much.
Okay, that seems to be all. Well, thanks, Dave. Oh no, there's one more. I'm over there.
So this is a more generic comment on really all the presentations in this session. Back in the grid days when Ireland was doing, TCD was doing the grid stuff for Ireland, they had a little copy of Ireland virtualized inside TCD. So whenever they needed to fiddle with a middleware stack or replacing certificates and stuff, they put it into their little virtual Ireland and tested it and so made sure that it worked. And then it was a little more complicated, but once it worked, they could press a button and things would go out into the real Ireland. And it strikes me that many of these virtualizations of networks and things would enable the same kind of testing, that you could have a virtual country somewhere virtualized. And you can test things, or maybe you can replicate scenarios like denial of service attacks and stuff. And once you're happy or have proved your point of something, you can replicate your setup in the real country.
You're dead right. I was looking at this actually with my blinkers on, operational blinkers on of I can get around change control like this because we know what the thing is going to do. But that's, in some way, it's a much bigger picture than that. You're quite right.
You can't get around change control with this.
We can agree on change control with this.
Okay, thanks very much, Dave.
Thank you.